Okay, Assalamualaikum dear students. My name is Asim Jan, lecturer chemistry at Woods College, Peshawar. अच्छा ओके, आज जो हमारा टॉपिक है, ठीक है, वो चैप्टर 4 फर्स्ट ईयर से रिलेटेड है, ठीक है, दी स्टेट ऑफ मैटर 1 गैस स्टेट ऑफ मैटर, और टॉपिक है हमारा डिराइवेशन ऑफ आइडियल गैस इक्वेशन। अच्छा देखिए, सबसे पहले तो आइडियल गैस इक्वेशन के लिए हमें ये जानना जरूरी है कि आइडियल गैस लास्ट कौन सी होती है या आइडियल गैस होता कौन सा है। हम उस गैस को आइडियल गैस कहते हैं जो गैस लास्ट को, जो आइडियल गैस लास्ट है उसको ओबे करती है या आइडियल गैस इक्वेशन को ओबे करती है, तो उसको हम आइडियल गैस लास्ट कहते हैं, ठीक है। सो आइडियल गैस इक्वेशन, दिस इज आल्सो नोन एज जनरल गैस इक्वेशन। इसका दूसरा नाम जो हम पिक करते हैं वो जनरल गैस इक्वेशन भी कहलाता है, जनरल गैस इक्वेशन। ओके, क्या होता है ये, हम इसको कहते हैं दिस इज द कंबाइंड फॉर्म ऑफ आइडियल गैस लास्ट। सो द लास्ट इंक्लूड द Boyle's law, Charles' law and Avogadro law. So the combined form of Boyle's law, that of Charles' law and that of Avogadro's law is known as ideal gas equation, उसको हम कहते हैं। Now look here, according to the Boyle's law, what Boyle states? Boyle states that volume of a fixed mass of a gas is inversely proportional to the pressure. But look here, to maintain the temperature and number of moles constant here, we have to maintain the temperature and number of moles constant because the volume is a dependent variable, खुद ब खुद चेंज नहीं हो सकता। Once we kept the pressure, temperature, number of moles constant, the volume will remain fixed, उसमें कोई चेंज नहीं आएगा because it's a dependent variable, ये डिपेंड करेगा इन तीन पैरामीटर्स पे, प्रेशर पे, टेम्परेचर पे और नंबर ऑफ मोल्स पे। So let we maintain temperature and number of moles constant और pressure को हम वेरिएबल बनाते हैं, चेंज करते हैं। No, in that case by changing the pressure, volume will relate inversely. The point is that if we increase the pressure, then the volume must be decreased. This is according to the Boyle's law. Second law stage करता है the Charles' law. Charles ने actually relation of temperature पे जो है with that of volume जो है वो स्टडी किया हुआ है, और उसका आइडिया ये है कि volume is directly proportional to that of temperature, but there is a condition involved here. Condition क्या है? Number of moles और pressure को हमने constant रखना होगा इस Charles law को apply करने के लिए। So number of moles and the pressure constant, then temperature and volume are directly proportional to one another. This is Charles law. तीसरी आइडियल गैस लॉ है Avogadro law. Avogadro law कहता है कि volume is directly proportional to the number of moles, but wants the temperature and pressure to be maintained constant. ठीक है? तो what is ideal gas equation? So let we combine Boyle's law, Charles' law, and Avogadro law. So we will take the combined form of these three laws. So look here, we just are going to combine these laws. So look here. Now to combine. Now look here, to combine gas laws or combines equation 1, equation 2 and equation 3. Equation 1, equation 2 and equation 3. So let's combine for volume. So volume is proportional to the inverse of pressure according to Boyle's law, directly proportional to temperature according to Charles' law, and directly proportional to the number of moles according to Avogadro. So what we get from there, we get that volume is directly proportional to number of moles, temperature, and inversely related to pressure. So we have to skip this proportionality by equality and a constant here, because the point is that now once you replace the proportionality from any equation, then that is replaced by an equal sign and then by a constant here. So look, volume that is equal to, we have to add here a constant, and here is the constant is capital R. Number of moles, temperature divided by pressure. So what is this R basically? So R here, this is known as universal. Look here, what it known is known as universal gas constant. So let's rearrange this equation. So we rearrange this equation, and that is equal to PV is equal equal to nRT. So this equation is known as ideal gas equation. This equation is ideal gas equation, or is also known as general gas equation. Both are correct, ideal gas equation or general gas equation. Let's take the standard form of the ideal gas equation for the initial and final state of the gas. Let अगर हम इसको ऐसे कंसीडर करें कि यह गैस जो है वो इनिशियली उसका टेम्परेचर, उसके नंबर ऑफ मोल्स, उसका प्रेशर, उसका वॉल्यूम क्या है, ठीक है, और फिर उसमें हमने प्रेशर में चेंज कराया और टेम्परेचर में जो है वो चेंज हम उसके लेके आए हैं. So what will be the final state of that system? What will be the volume at the final state? What will be the pressure at that case? And what will be the temperature of that gas? So look here, we'll move to the standard form of the ideal gas equation. So look here. Now if an ideal gas, look here, if this is at initial state, so at initial state, the R constant will remains constant. So we have to write here, this is PV product by number of moles and temperature. So for the initial state, look here dear student, what we have to do here, we write the pressure 1, volume 1, number of moles 1 and temperature 1. So look here, we have to make number of moles constant here. So right here that number of moles to be maintained constant, so we will skip the number of moles from this equation. So here R is equal to pressure 1, volume 1 and temperature 1 for the initial state of the system. Let me change the pressure. Let for example we change the pressure. So by changing the pressure, then definitely there will be change in volume occur. Maybe there is we change the temperature as well. So at final state, what will be its constant? So at final state R, this universal gas constant is equal to pressure 2, volume 2 and temperature 2. So as we know that the constant will remains constant by changing all these parameters. So we combine these to form the first one for the initial state, the second is one for the final state. So what we get that P1 V1 divided by T1, that's equal to P2 V2 divided by T2. This form is known as a standard or generalized form of ideal gas equation, जहाँ पे 6 पैरामीटर है, 2 pressure, 2 volume and 2 temperatures. So dear students, याद रखें, अगर आप लोगों को कोई ऐसा न्यूमेरिकल जो है वो गिवन हो जिसमें आपको 5 पैरामीटर्स गिवन हो और 6 पैरामीटर के बारे में जो है वो क्वेश्चन पूछा जाए कि सपोज आप इसको मालूम करें, तो लुक हियर, इसके लिए फिर आपने ये वाला इक्वेशन जो है वो अप्लाई करना है, जिसमें आप देखिए 6 पैरामीटर है, 6 पैरामीटर्स, 2 प्रेशर है, 2 वॉल्यूम्स है, 2 टेम्परेचर्स है. तो हम उसको एक उस पैरामीटर के लिए रीअरेंज करेंगे जो क्वेश्चन में जो है वो डिमांडेड होगा, ठीक है. सो लुक ओवरव्यू दिस वन, मैं थोड़ा सा समराइज भी कर लेता हूँ दोबारा से इसको कि आइडियल गैस इक्वेशन या जनरल गैस इक्वेशन हम कंबाइंड फॉर्म ऑफ गैस लॉस को कहते हैं, ठीक है. बॉयल्स, चार्ल्स और गेटोस लॉ, ये तीनों आइडियल गैस लॉस कहलाती है. इसको मैंने वन बाय वन जो है आप लोगों को स्टेट किया कि वॉल्यूम इनवर्सली रिलेटेड टू प्रेशर, डायरेक्टली टू टेम्परेचर, डायरेक्टली टू नंबर ऑफ मोल्स अकॉर्डिंग टू दीस थ्री लॉस, और फिर उसको जब हम कंबाइन करते हैं, ठीक है, तो कंबाइन फॉर्म में हम जो इक्वेशन ऑब्टेन करते हैं वो होता है PV is equal to nRT and that is known as ideal gas equation. While for the initial and final state of a system जो gaseous system होता है, तो initial state में by keeping number of moles constant for both state, तो universal gas constant P1 V1 divided by T1 के बराबर है for initial state. हम just rearrange कर लेते हैं ideal gas equation को, और final state में dear students हम क्या कर देते हैं, कांस्टेंट यहाँ पे बराबर है प्रेशर 2, वॉल्यूम 2 एंड टेम्परेचर 2. So to combine the initial and the final state, we get a generalized or a standard form of ideal gas equation where P1 V1 divided by T1 is equal to P2 V2 divided by T2. So this is known as generalized form or standard form of ideal gas equation, while this one is known as ideal gas equation. इक्वेशन। ठीक है जी।